How's it going, everyone? My name is Chad, and I guess I'll call this a series called Ask ChatGTP in order to raise awareness of the dangers of overusing LLMs for software development. I see that there are CTOs, product managers, firing entire development teams because they want to save like $15,000 a month or something like that, when the risk is real. So let's enter something into a chat. So let's go full out, like worst case scenario. What would happen if what could go wrong if a vibe coder programs a radiation therapy machine? Short answer, a lot, and some of it could be fatal. Who would have thought? Alright, long answer below, structured by how things can go wrong and why vibe coding is uniquely dangerous here. Vibe coder, in this context, a vibe coder prioritizes speed, intuition, copying patterns, and it works on machine over formal specifications, verification and validation, safety proofs, regulatory discipline, adversarial thinking. What if it fails? The approach can be fine for marketing sites, prototypes, CRUD apps, internal tools. It is catastrophic for radiation therapy machines. Alright, so silent those miscalculations. Alright, I mean, this is going into a lot of detail. I mean, look at all this stuff. Alright, so radiation therapy is about exact energy delivery, and these are based on prescription. So when you are undergoing some kind of therapy, or for anything, it could be eyeglasses or whatever, there's always a prescription written, and it's given to someone like a radio tech, a pharmacist, someone at your local eyeglasses store. So let's see, wrong units, GY versus CYGs. I'm not sure what those means. Rounding errors, floating point drift, especially if you are writing something in C++, where significant figures and precision is very, very important. Off by 1 in beam timing, incorrect delay curves. A vibe coder might trust defaults, eyeball numbers, clean up code that looks redundant. Result, underdose, cancer is not treated. Overdose, tissue necrosis, radiation burns, secondary cancers. Patients don't get an error pop-up, they get injured weeks later, or it could be immediate. It could be like you're in that machine and you are just getting burned. Race conditions and timing bugs. Radiation machines are real-time systems, so beam on or off. There's no in between, it's just binary. Gantry rotation, patient positioning could be, very important. Interlocks of doors and shields. A vibe coder might ignore concurrency models, rely on async callbacks that usually works. Skip deterministic scheduling. Result, beam fires before position lock, beam continues after abort, safety interlock, bypassed by timing bug. It is not theoretical. It has happened. With that said, let's bring this over here. Have you heard of the Therac 25? So apparently back in the 1980s, so there was a previous generation of this machine, and this version of the machine had mechanical lockouts. So when they upgraded the machine and they wrote the software for it, they didn't take into account that there is a lack of mechanical lockouts. And if the radio technician entered the prescription into the program wrong in like in a certain order, like they go do something, change something, go back, it has to be a very precise like sequence of events. There was actually over radiation at the site of treatment, and that actually involved some fatalities, unfortunately. And the fact that we're not learning these lessons again, and we're just vibe coding, and this isn't just life or death, it could be your business. I mean, shipping a full-blown app and not verifying it, not thoroughly testing it, just vibe code it, copy and paste into your IDE and push to production, that could cause a whole lot of issues. There's other things like unsafe UI assumptions. Radiation operators rely on precise status indicators, confirmations, alarm hierarchies. I do not know anything about these machines, so I'm just taking it as is. A vocoder might debounce incorrectly, auto-submit values, reuse UI components not designed for safety, suppress annoying warnings, and the result, operator believes the beam is off when it's on, wrong patient plan selected, override applied and unintentionally. This was the root cause of the Therac 25 incidents. And it just goes on and on. There's ethical failure, not just technical. See, missing fail-safe design, safety critical machines assume the software will eventually fail. A vibe coder often assumes if it compiles and tests passes, it's fine. Missing elements, hardware interlocks independent of software, watchdog timers, redundant checks written by different teams, defensive programming against impossible states, result single bug equals uncontrolled radiation. So let's go look at, let's dig into this a little bit more. So if you are programming a radio machine, would you throw an exception while it's delivering its treatment to a patient? You throw an exception, an error pops up, the machine is still running, the mechanical part. It's now, the mechanics and the software are now out of sync. And this is true in certain systems like flight hardware systems and fighter jets. When you are writing software where someone's life depends on it, you're flying a jet at 1,000 miles per hour or knots, you don't want to see buffer overflow exception. I'm out. Eject, get the heck. You got to handle that error. You don't throw a exception, you handle it, and you make sure the software keeps running. There are particular standards for writing software for flight hardware that goes in combat systems. There is, I think it's a Joint Striker standards or something like that. It was written by a military contractor. No formal verification or traceability. Medical systems requirements traceability, hazard analysis, version audits, reproducible builds, documented assumptions. A bytecoder might rely freely or refactor freely, skip challenges or change logs, simplify logic, without knowing why it exists. Remove checks that never trigger. Results: regulators can't verify safety. Hospitals can't trust updates. Bugs reappear years later. Testing illusions. Typical vibes testing. Happy path tests. Mocks that don't match hardware. A lot of this stuff is proprietary. So ChatGTP or Claude has no idea what is the API for this type of machine. No fault injection, no boundary testing. What's required instead? Hardware in the loop testing, simulated sensor failure, power interruption tests, cosmic ray level bit flip tolerance. Yes, really. So what is... Let's go look into this. Alright. Cosmic rays really cause bit flips, especially in outer space applications. So when you design hardware for space systems, usually you have 2 bits or 2 values. So you have a low voltage value for 0 and a high value voltage for 1, and the tolerances or the space between these values, so there's a no zone, like there's no really defined values between these 2 ranges of voltages. So tolerances are different for home, commercial, and space grade hardware applications. So yes, in computer memory, changing zeros to ones or vice versa leading to errors can occur, which is known issue in high altitude computing, space, supercomputing. Yep. I said it. Supercomputing with protections like EEC memory being crucial but not foolproof, requiring layered resilience strategies for critical systems. So these are systems where people's lives could depend on, and if some kind of hardware fault occurs, people's lives can be at stake, either up in the air or on the ground, or both. Ethical. This is the part people underestimate. Vibe coder mindset often says, we'll fix it if something goes wrong. In radiation therapy, the patient pays first. They pay a lot. Rollback is impossible. Harm may be reversible. Casualty is delayed and hard to prove. This creates moral injury to staff, lawsuits, loss in trust in medical technology, and preventable deaths. And this is one thing we want to prevent as an engineer. We do not want our software to cause any harm to other people. And this is why I'm doing this. This is my duty to warn you, the product manager, the CTO, who is laying off your staff right now because you do not want to pay software developers. You just want to create a Claude membership, install an IDE, and start coding. Historical precedent. This already happened. The Therac 25 radiation machine in the 1980s. Software replaced hardware interlocks. Race conditions allowed massive overdoses. User interface hit critical state. Engineering dismissed the bug errors because they'd never seen the error before. They didn't know what to do. They're just like, all right, let's just go for it. At least 6 patients were severely injured or killed. No hackers, no malice, just bad software culture. The core lesson: vibe coding assumes software errors are annoying. In radiation therapy software, errors are lethal. Critical software requires paranoia, humility, documentation, redundancy, boring code, slow and deliberate change. You can't say, hey, it worked in development, ops problem now. If someone says this should be fine and it works in testing, they should never touch a radiation machine. So this is because I talked to ChatGTP about some other stuff. So how will this apply to what I already understand? So given my background, I'm a systems engineer. I support aviation research. I do a lot of automation, configuration baselines across hundreds of computers. Things has to be right. Defensive design, building frameworks with explicit contracts. And it says you already think ahead in the correct mental model. Design for failure, not success. And this is also goes on from back in my computer science training, where the Therac 25 was one of the first things that was discussed. It's like, don't write software that kills. And this is a rhetorical exercise to see what ChatGTP can come up with when it comes to a realistic answer. I mean, it doesn't know what it's doing. I ask a question, it searches the internet, and it just kind of formulates strings of words that somehow now make sense after years of work, you know. And it's always improving, and there's always a lot of slop, and that's one thing. If you like this video, I can go make another one about what if you vibe code an entire operating system and try to ship it to production. Oh, Microsoft slop. And I believe that is it for this video. Thank you for watching, and we will see you next time.